Sample 1 impact on deep impact mission. We've seen comets hit, in fact, the surface of Jupiter. That's what those black spots are. We observed that with Galileo spacecraft. Here's the impact. Here is Hayabusa, which is the Japanese exploration of an asteroid. I mean, you couldn't have created that in science fiction. You know, that just wouldn't look like that. It's too bizarre. And here we landed on the surface there. They actually have a sample on the way back. We hope it made it. We hope it's into the spacecraft, and it's coming back to the Earth. An incredible mission by the Japanese. We also went through the outer planets and satellites and are still there. We started out with Voyager 1 and 2 and got unbelievable views of Jupiter, Saturn, Uranus, and Neptune and their zoo of satellites. We knew we were out in outer space when we were looking back. This image is just monumental to me because it says we're looking back towards the Earth from beyond Saturn. Not the rings I'm used to, but a shadow on the rings from beyond. We saw a veritable menagerie of satellites, giving us different perspective on how these things worked. In the Saturn satellite system, look at them listed here. Look at the rings. All these things were teaching us about the formative years. Uranus satellites were equally interesting and diverse. Miranda itself, if you take a look at this, has unusual things. It's only a couple hundred kilometers in diameter, but it has these huge plates. It's almost like pastry puffing up, revealing layers of the interior by forces we have no clue about. We took a look with Galileo, and now we're going into orbit around these outer planet satellites with Galileo and Cassini. We saw, in fact, Io. There is no impact crater that's been detected here because, in fact, the surface is so young because it's constantly being resurfaced by volcanoes, all of which you can see here. That's an active one right there. We saw, in fact, Europa, an icy satellite, which is very likely to have a liquid water ocean just beneath the surface. Take a look at this. If that doesn't make you think of ice on a spring ice-covered pond breaking up, I don't know what does. There's very likely a thin crust of ice overlying a couple hundred kilometer thick ocean, and this is a real possibility for life there. The other two satellites, Ganymede and Callisto, are the size of Mercury and very different from each other. Again, lessons in the evolution of planets that we're learning from the analysis of these satellites. Cassini has been no less impressive. This is Enceladus. This is an active volcanic eruption, except it's water ice and other kinds of things. Gas is coming out. That's what this is. Here's the structure here. You notice there's no craters here. This thing is actually erupting. Flown by it and through it a couple of times. Unbelievable data on the nature of how these things work, even with these small bodies. Just different perspective. And of course, Titan, the jewel of the Saturnian system, with an atmosphere. We've actually landed on the surface. This is what the surface of Titan looks like, with rocks that are not made of silicates like we see rocks on the Earth, but other things like water and ice and clathrates and other methane and other types of features. And when we look down, it's looked like you're coming into, say, Long Island and southern New England here. Look at these rivers. Look at this thing sticking off the coast here. This is on the surface of Titan. And these are probably methane lakes and oceans. There's all kinds of hydrocarbons in the atmosphere. This could well be what Earth was like in its earliest history. So these are insights we've gotten. And of course, we have New Horizon. It just flew by not too long ago. The Jupiter system took a look at the erupting volcanoes, and it's on its way to Pluto. And again, you know, I know you got all your calendars out, July 14th, 2015. Put that down because that's the current date of the closest flyby. It'll be within a few thousands of kilometers and get unbelievable information on Pluto and its 4 moons. 4 moons. And the sun. Let's not forget the sun, because in fact, we tend to, as planetary scientists, forget about the sun. But what we find is that the critical role of the sun in planetary evolution, it's the King Kong of change. If you think about atmosphere change, you think, oh yeah, the weather's so-and-so today. The big secret is that the sun is a variable star. That should scare the hell out of you, actually, because you're thinking about it as being constant, but it is a variable star. It's been variable over lots of time scales. For example, the sun, we have sunspot cycles. We have 500-year cycle, we think, coronal mass ejections. One of these happened in 1859 and completely wiped out, Cuba was seeing aurora borealis. Cuba, okay, down in the equatorial regions. And over the course of a couple of days, the complete communication, telegraphic communication system was taken over by this flux, okay? You couldn't do anything. Messages were being sent by the flux, not by people, okay? If you think that an EMP would be interesting. This would be interesting too, and it's in store for us. We just don't know the time scale. This is something we really need to understand. There was probably a faint young sun. What does that mean? That means it wasn't like it was today, and we certainly had global ice ages in the earlier history of the Earth. These are all things we don't fully understand. Let's come back now to Earth, the home planet, and finishing up today. So what has all this exploration done for us in changing our perspective? If we come back to the Earth, we in fact come back to the Earth with this new perspective. The solar system, billions of years, and we can now fit in much more readily the chapters of the history of the Earth. And we know the Earth much more now than we did before. We have new perspectives on where we've been. We have many of the chapters, the missing chapters in Earth history. We know, for example, we have perspective on these. Impact cratering is a critically important thing which we never would have thought about. Ask the dinosaurs, for example. They know, or they knew. It's critically important throughout the history. Global resurfacing, something we wouldn't have thought about on the Earth, may have started plate tectonics, could be happening in our future. Who knows? Radical climate change and snowball Earth definitely had global glaciation on the Earth early on in its history. And of course, life. We have new perspectives on hospitable environments. And this is really important for understanding where we came from and actually how we indeed originated in the first place. All this is brought from our perspective from the planets itself. And we have a concept that we no longer view the Earth in isolation. We used to be, not too long ago, the center of the cosmos. It wasn't until Copernicus that we were made aware that actually everything isn't revolving around us. And if you think about everything revolving around us, it kind of reminds you of, you've all had this experience as parents, a 2-year-old, okay? Well, you could argue that humanity was 2 years old at the time Copernicus pointed out, hey, the Earth the cosmos doesn't revolve around you. And that puts us in a position now that's not too much older than 2. Okay, so think about that, because that's the kind of perspective we need to press on. We have all these kinds of questions. We need to understand life's origin. We need to look at radical climate change, how the crust was formed, and we need to look at Pluto, because it's there, okay? That's how we learn. Where are we going in the future? Let me close by just pointing out the fact that the next 50 years of NASA should be really, really exciting. Now, it's not going to be the way it was in the first 50 years. There are going to be international space races, so to speak. The present situation at the moon, the Earth's moon, is that there are 2 spacecraft in orbit, 2 beautiful spacecraft, heavily instrumented. One of them is Japanese and the other is Chinese, okay? We're not there, folks. Next Wednesday, we're launching, indeed. Professor Carly Peters at Brown has an experiment on board the Chandrayaan that's supposed to launch next Wednesday. That will bring the United States back into the fold on an Indian spacecraft. Hey, if you got a ride, take it, okay? The U.S. spacecraft, Lunar Reconnaissance Orbital, it's slipped again. It'll be next April sometime, hopefully. So we're going to be a latecomer to this. We're getting a ride with the Indians, so NASA's paid for this instrument, and we're hoping that's going to revolutionize our look at the moon. We also have Dawn coming up soon. Professor Maria Zuber and Professor Carly Peters are key players in this. This is another thing about geologists. I'll just mention one thing, that a geological hammer, which is our tool of the trade, is a really good thing to break glass ceilings, and they've done an exceptional job at that, as they should. We also have this. There is no doubt in my mind that in the not-too-distant future, we're going to be flying airplanes on Mars, on Venus, on Titan, on the outer planets, and beyond. There's no doubt in my mind. This is a technology that you all have developed. It's waiting to be applied in detail, and I am sure we're going to do it if you all keep up the push as Joel has done over the years. This is an exceptional opportunity. It's going to be the harbinger of what's going to happen in the next decades. And of course, we're going to send rovers to other planetary bodies. We're going to send humans back, and hopefully they will give us more of a legacy than Apollo did. Apollo gave us an incredible legacy. It's our challenge, as you all think about human exploration of the moon, to make sure that built into that is a legacy that is at least as good as Apollo. You can do no less than Apollo. That was 30-some years ago. You can do no less than Apollo, and you ought to have that on your mind every day as you work on these things to, in fact, make exploration of the moon not by sodbusters, but by pioneers and cowboys, okay? You've got to get out there and you've got to explore. Of course, we're also going to go to other planetary bodies. But we're not going to do it with spacecraft. We're going to do it with remote sensing instruments, and we're going to now go into comparative planetary systems. This is an interesting solar system. We start out on the Earth. That's our home. We look at the neighborhood. As we grow up, we begin to understand that we're part of a family. And then, of course, you begin to take your first trip